to talk to us today on MP units. So Mateusz is a software architect, principal engineer, and security champion with over 20 years experience designing, writing, and maintaining C++ code, both for fun and for a living. His main areas of interest and expertise are modern C++ code performance, low latency, safety, and maintainability. As a founder of Train IT, Mateusz provides dedicated C++ training and consulting services to corporations worldwide, drawing on over 15 years of teaching experience. He contributes to the industry as a conference speaker and as an active voting member of the ISO C++ committee, where he helped shape the language's future alongside the world's top experts. So he's committed to software safety and is also the founder and primary author of the MP Units project, which he's going to tell us all about today. This is an open source library that strives to make the world safer by ensuring correct handling of physical quantities in software. So welcome, Mateusz. It's very nice to have you with us.
Yeah, thank you. Welcome, everyone.
Stop sharing, and yeah, if you're good to share, then we can get started.
Okay, I'm sharing them.
That's wonderful. Yep, we can see the slides.
All right, good. Thank you. I will just set up everything so I can also see you in case you will have any questions. Because my window moved somewhere. Oh, it's moved here. Strange. I sometimes hate Zoom with those windows. Okay. All right. Okay, so welcome everyone. Again, my name is Mateusz Pusz. I'm the founder and the main author of the MP Units project. And we are going today talk about how we can improve safety in your domain, right? So we are going to talk about quantities and units. And especially I would like to put more attention on this quantities word, because typically you think about units libraries, maybe not necessarily quantities. So I will try to actually describe what I mean by this and what are the benefits of using that. But first, let me introduce myself. I was briefly introduced before, but I will repeat myself also briefly. So my friends call me modern C++ evangelists, which means that I love sharing my knowledge and my experience with others. That's why I'm doing lots of things in open source. I'm doing this for fun. I'm doing MP Units for 7 years right now, right? 7 years of this project. And then plenty to come, actually, because this project is not finished. And also we plan to standardize it in the ISO standard, hopefully C++ 29, but if not, 32 is also available. I'm active voting member and contributor to the standard. So I'm there for like 3 last cycles already. So you can blame me for some of those changes. I'm also trainer, coach, mentor, consultant, and conference speaker. This is my main source of income, of basically of money. So I try to live from that, right? This basically means that as a freelancer, hours spent on open source and ISO committee actually takes me out of my paid work, which sometimes is a conflict. So in case you actually find my work valuable, please consider maybe sponsoring me or hiring me as a trainer for your needs, for your teams to train you with modern C++, for example, right? I need some money for living as well. I cannot do open source all the time. And it's sometimes a conflict. Also, a short disclaimer. I am not a high energy physics expert, right? I'm not the expert in this domain. I am expert in C++. I'm expert in type systems. I am expert in zero cause outcomes abstractions. And this is what I do the best, right? For this for this talk, I try to provide some domain examples, your domain examples for the code, so the code is more familiar to you. If there are any, let's say, not the best ideas there, please let me know. But please bear with me that I'm not the expert. I just asked LLMs sometimes to actually help me understand the domain and provide better examples that will better suit your needs. So if something is off, just let me know. It may happen, but the type safety and type system, strong types and safety and performance is there. All right. Right, so I don't probably need to introduce you to the domain too much, right? You know high energy physics. You know that safety is really important about correctness and the reproducibility of the experiments you do. We trust the software with complex detector geometries, critical tracking deconstruction algorithms, multi-day simulations on the grid, and so on, right? The problem is that a single unit mismatch in your software may actually prove to actually surface after long hours of simulations, or even may not be found, and then you have off results in the end, right? And these simulations and the software runs for many minutes, hours, and so on. So if there's an error, it would be nice to catch it early, for example, at compile time, rather than late when you see that the results are somehow strange. And yeah, you have lots of code, right? In only a Tena project, there is 2.5 million lines of code, right? And also multiple frameworks are being used. And those have also inconsistent units as base units selected and use different code data versions for constants and so on. So there's plenty of challenges here on how you can address them with type safety. And training alone won't solve it, right? You can train people, tell them that there are different projects, they have different defaults, and so on. But in the end, when you're writing code, everyone is a human, everyone can make mistakes. And if compiler will not protect you from that, those errors will happen anyway, right? And probably it happened to you before, right? Everything is just a double. And because of this, you can provide anything through this value. The different unit, different quantity type, everything will be accepted by the compiler, and then only you will find out that results are off. Compiler, can you help you much, right? So if you see examples like that, this is just one of many examples from one of many projects, right? With plenty of doubles being used as an argument, it's so easy to provide them in a different order, right? And this will just compile, and it will be incorrect, of course, right? And there are many others, right? In the root project as well, you have this time different quantities of different types: magnetic field, angle, length, energy ratios, mixed with the same type provided to the compiler. Right? So they are all convertible to each other silently. And there is one of my favorite ones, particle definitions. It has plenty of those arguments passed, and it's so easy to make them in a wrong order or with wrong units. So probably it happened to you more than once that you passed actually the arguments in incorrect order. You create mass and width, right? That's actually rest energy, not mass. So it might be surprising to see such a name here. And then you provide them in an incorrect order, it compiles, and you find the results are hugely off, right? Particle rest energy is 3000 magnitude wrong, and the decay width is absurdly large. And this may be caught in the physics validation or never, depending how the tests are being provided. So probably know those issues. I don't have to introduce them too much to you, right? There's also the problem with magic 1.0 value, right? Depending on the project you use as a dependency, you may use different defaults for 1.0, right? Here you have 1 millimeter, in the root you have 1 centimeter, 1 nanoseconds, 1 second, 1 radian, 1 degree, which is quite a lot, right? 1 mega electron volt, giga electron volt, right? So 1000 order of difference. Also for time, it's a huge difference, right? Between seconds and nanoseconds. So if you don't know, or you're not aware, or you forget about converting those defaults between different projects, your results will be off as well, and nothing will protect you from that. All right, so if you get something from root and you pass it to other projects without any conversion, probably you will have incorrect logic. You have to remember always to convert those. And it doesn't help that different projects from different classes from different projects actually use or describe similar stuff, but provide parameters in a different order and unit as well, right? If you look to the TGO cone and G4 cones, which do something similar, they will have different order of parameters, which is hard to match and provide correct order for them. If you want to bridge those different projects, you need to provide manual scaling factors. And if you will forget, you have plenty of errors or big errors. So those are the big errors. There are also small errors that are possible in new software, right? Different projects will use different code data versions, and those will introduce small errors if you will not use the correct version, right? For example, here we are having the value from the code data of 2014 for electron mass. As you can see, it drifts a bit because it starts to be more and more precise with the latest version of code data. And of course, it's not a huge problem in the value, but it will if it will accumulate, it may actually provide some off results. Right now, you have to hope that everyone knows what happens, and basically you somehow convert between those or try to make it consistent. With the strong type solutions, with naming those properly, you will have compile time assurance that everything is correct. So those were the problems that you face, and you probably know already, right? So now let's talk about MP units a bit. The design philosophy of MP units is to provide compile time safety, right? You want to correctly handle physical quantities, units, and numerical values with zero runtime overhead, right? You don't pay at runtime at all for all of those abstractions I'm going to talk today. They are as fast as working with fundamental types. Same assembly as handwritten double code, or faster, as I will prove you later on. Great user experience, right? Modern C++, NTTPs, concepts, formatting, optimized for readable compilation errors. And for the last 2 weeks, I was learning your domain, and I also provided HEP-specific system in MP units that actually tries to address your needs. We have dedicated system of quantities that actually models how you work with quantities on daily basis. It's not the same as ISQ, so International Standard of Quantities, because you use different base quantities, right? You use energy, for example, as a base quantity, and this is not the case for ISQ. I also implemented all of the code data versions for 2014, 18, 22 in separate namespaces, so you can actually easily refer to them. And it also supports scalar, vector, tensor quantities, and it's easy to extend for custom experiment units or quantities if needed. And it's also meant to be standardized as a part of C++ 29, as I said. So hopefully those will be stud units or stud quantity in the future. I provided some papers for this. If you need, you can actually refer to them and read more, or contact me. I am eager to talk about this all the time. And we have here 6 levels of safety, right, in typical libraries, or maybe not typical, in MP units. First level of safety is obvious. It's a dimension safety. Every Unix library provides that, right? It prevents mixing incompatible dimensions. This is something that you expect from the Unix library, something that you mean when you talk about Unix library, right? Another one is unit safety. That's also probably the thing that you think about, right? This is about scaling units for you, right? So you don't have to think about it. The framework will either scale the value for you or will provide compile time error if, for example, truncation is involved. All right. So those are the obvious things that you also know probably from Chrono and other libraries. The next one is representation safety, right? It protects against the precision loss and overflows, if possible. Then we have quantity kind safety. It prevents arithmetic on quantities of different kinds, but those kinds will have the same dimension, for example, like for example, solid angle and plane angle, right? Or frequency and activity with Hertz and Becquerel, right? So those should be independent domains, and you should not be able to mix them in one equation, comparing or adding them. Quantity safety. It goes even more and provides multiple quantities of the same kind, like multiple lengths or multiple energies, and treats them separate, which is a huge win for type safety of the interfaces. And last but not least, affine space safety, right? So you can talk about points and deltas, which is really useful when you deal with those in the interfaces, right? So each level of safety adds another level of protection for your domain, for your code, right? And you can encode your domain easily through those abstractions. You can encode this directly into type system. So let's see from the very first, the easiest one level, right? Is dimensional safety. Right, so that happens probably a lot to you, right? You provide wrong arguments in function calls, right? Like invalid order, for example. Right? If you have a function like average speed in millimeters and time in nanoseconds, then if you specify bunch time and track length in here nanoseconds and millimeters, you will be able to pass them correctly, but incorrect order will trigger compile time errors. Also, providing something different, of course, will trigger a compile time error. This is obvious, I hope. Unit safety is about scaling, right? So if you, for example, take the value in millimeters from one framework and you want to pass it to another framework, you can easily convert it with just centimeters, and it will just convert it properly to your needs. Or the conversion will happen implicitly when actually passed to a function from the root interface. So you don't have to do it manually. It will happen also implicitly if needed. And even though they have different value and different units, they compare equal, right? Because actually the quantity value is the same, because quantity value is not just a numerical value, it's both numerical value and the unit. So together they provide the same value, even though they have different values separately, right? In a pair of types or values, right? You can also get the underlying numerical value, a double type from those easily, with numerical value in, and you also pass here a unit to make sure that you have a value in the correct unit. In case the unit is different of the quantity, the scaling will happen here as well. So you always are provided with the proper results in the end, and is basically safe, depending on how you modify or maintain the code in the future, right? You will always get millimeters here, no matter what G for radius is today or will be in a week from now. Right, so actually it eliminates a lot of bugs that probably you already faced. Right, you don't have to manually scale by factors. Compiler will handle conversions. In case of unit, if unit match, basically conversion optimizes away completely. There's no cost for that. The next one is representation safety. If you played a bit with stud chrono duration, for example, you know what I mean, right? Chrono treats the integral types as potentially losing precision, and floating point types as value basically as value preserving types, right? So if you are playing with integer, right? It's just integer one written from some ADC, and then you want to convert this to a voltage. You multiply it by double, and you get a double in the end. So this quantity uses double under the hood, not integer anymore, right? Because it was multiplied by double, it basically follows the underlying system or underlying language rules for conversions of the values. Then basically we convert from voltage to energy, and we have all of this here. This row ADC is being converted to a double, and you store doubles in this quantity as well. And then if you want to assign this to integer, you will get a compile time error saying that passing a double to an integer is a truncation conversion, and this doesn't happen. That is not allowed, right? In case if you want to force it, you have to either use value cast or forced in member function. I know that the name may be not the best one. We are looking for a better one, but for now we are using force in. We specify the representation type and the unit, and then this truncation will be happen, but it's explicit in the code. Easy to find and easy to see during code review. Next level is quantity kind safety. I was looking for some domain that actually you may actually have this issue. Probably, yeah, well, you're using the frequencies and activities with becquerels, right? So Hertz and becquerel, but probably not in the same part of the software. So probably you may say this never happens to us, that we actually mix those two. I thought that maybe you're using sieverts and gray, but I've just found only grays in your code or headers, but not sieverts. So also this might maybe not happen to you. But another possibility is, for example, radian and steradian, right? Those may be modeled as dimensionless or strong quantities. Depending on your feedback, I can model this for your system as you need. Right now, I model this as a strong type, so actually it's not the best. Actually, those are not the kind issue right now. So I ended up with this kind issue here. I modeled proper time and coordinate type time, both of them being time in nanoseconds, to be separate subkinds, because you don't want to mix those, right? Those are different, those are incompatible. You should not mix them in the same equation, right? You should not compare them, you should not add them, because they have totally different reference frames. And you can do it easily with my library by just providing a simple annotation to the definition saying this is a separate kind of time, and basically it should not be mixed with others. Right? So this prevents also bugs like that. Of course, you can divide them to calculate gamma, but you cannot add them or compare them directly because they are different abstractions of time. And you can find more probably like that if you will look closely. Quantity safety is about providing different quantities of the same kind. Like for example, I can specify trap half for the z, y, x axis, tilt angle and shear angle, and then refactor our G4 trap that I shown you before code with strong quantities that will provide explicit lengths and explicit angles, and this will prevent us from passing the incorrect order of arguments for them. Of course, for these cases where you pass like dx1, dx2, they will be known, but also you may go even further and provide even more specialized quantities for 1 and 2 if needed, right? It's up to you to specify how safe and how granular you want to be. But with this, you create the quantities in this way. You say exactly which length you mean and provide the value. And then those will be strongly typed and will not be able to be reordered in the argument. Right? If you reorder with the angle, of course, you are ending up in a level 1 in dimensional safety because it's just angle and length. But in case you provide different length because you provide y here instead of z, then you end up with compile time error. And this is exactly this level of safety, right? Also, actually, this works on the so-called quantity trees. So there's a hierarchy of quantities involved. So you can actually add z and y. So those are not separate domains like in the previous case on the level 4. Those are in the same domain, so you can add them. But the result will be neither of them. It will be a common base for them. So actually, the result of adding this, for example, and this will be the common one, so the HEP length, because they both inherit from HEP length, and this can be found easily with this check, right? And this HEP length will not be convertible to any of those implicitly. So you'll not be able to pass the result to any of the arguments of this function. You'll have to be explicit about the conversion again, but it's possible. Last but not least is affine space safety, right? You have points and you have deltas. You can specify points that are or origins that are implicit, or specify explicit origins if you want to have more safety. And you create a point by providing an origin and a delta from the origin. You can subtract 2 points, and those are points, and the result is of course the delta. And you can create another point by getting a point and adding the delta, right? Adding 2 points is impossible, and this is prevented at compile time. So your logic is more complete with that, right? And you can provide many different origins. You may specify implicit, absolute ones, relative ones. So relative will actually allow you to translate from one origin to another. There's a lot of power in this design. So those are the basic level of safety that we get in unit libraries and quantities libraries. And there is more features that actually you could be interested in. I know that you are not using those right now in production because right now it's impossible for you to use those, but you could use templates for your functions, right? I didn't see any templates in your functions nearly because everything is just a double. And if you make a template double, you don't know at all what you are dealing with as a quantity or a unit, right? Because you have to pass specific units to the interfaces, so they are explicit in the interfaces. But if you have types, you can pass any quantity and any length, any quantity and any unit to a function and get the result in those specific units, right? So I may specify like decay vertex position that will take quantity point of position vector, quantity of decay length, quantity of angle, then do some operation on that and returns the position, right? And then I can pass here millimeters and degree, simulating I'm working with one project, and then passing centimeters and radians, simulating I'm working for another project, and it will always return me the correct result in this project's unit. I don't have to convert inside and out, in and out to units, which is expensive at runtime, and you have to remember about this. Otherwise, you have broken results, right? This happens automatically, and there is no overhead because it just works on the input units and provides the output unit in the same unit that was provided as an input. And there is really safe because you provide explicit quantity types you expect. So it will take any quantity of this type, no matter what is the unit and no matter what is the representation type provided, which is a huge benefit for safety and performance. As I said, for now, you don't use those templates because you can't, but maybe it's a possible use case for you. Another thing is adding type safety to dimensionless quantities, because if you think about units libraries, you think only about physics. But you have more things, right? You have efficiency, you have branching ratio, you have event count, you have yield. All of those are numbers with no dimension, physical dimension assigned. You can make them strong types as well with my library, and then specify that they are, for example, in a unit 1. So efficiency in a unit 1, event count in a unit 1, and you cannot reorder those in the arguments as well when you call those. Right? You specify this efficiency, branching ratio. You cannot add them because those are actually totally different domains. I make sure this with isKind, that those are separate domains. Right? So I cannot add the one-dimensionless number to another. I cannot compare them. I can pass them to functions, not in an incorrect order. And I can, of course, create ratios of them because you can always multiply and divide different quantities with no issues. And it's useful for many different things. So this will also change a lot of your interfaces that I analyzed, right? And last but not least, from bonus slides, we have faster light speed constants. And actually, to prove it, let's play with light speed constant. All right. C is a compile time unit in my library, not a double that you multiply and divide all the time. The same goes for pi, right? I've seen that you are having pi either in the header files of dependencies, or I have like m_pi in a Tana project, right? And you just multiply and divide by pi all the time. With this, there's no division, no multiplication. I'm working with 4 and 3. I could even use integers, and it will work fine, right? Because I have a unit of gigaelectron volt per C or C squared, and this is a part of the type, not the value of it. So if I do then the hypot, right? So I calculate energy from that. Actually, I never actually touch C. I never had to multiply or divide or power the C. I could work on integers, as I said, right? And get the 5 as a value in gigaelectron volts because C will just go away. All right. So you can see actually printing here those values. This value, when I print it, it will be printed as 4 gigaelectron volt per C. And only if I force the conversion to be in kilograms meters per second, I will get the actual value because C will be calculated or involved in the value, and the multiplication will happen. The same here for mass, right? Notice that I'm using mass as gigaelectron volt per C squared, not kilograms. And only if I say in kilograms, I will have to account for C. And the same for energy, right? It was just 5. So what the compiler does, it was just 4 squared, 3 squared, and square root 5. It could work on integers as well. And only if I will ask for joules, I will get the proper value. Right? So this is a huge benefit. And it's not only for C, it's for all of the other constants that you use. Planck constants, and another constant, and also for the constant pi. And any other constant you want to introduce. Right? They are just part of the type, not of the value. And they will be multiplied or divided when you actually ask for a specific unit that requires this conversion. That's a huge benefit for your calculations in terms of runtime and precision. Right? And in many cases, maybe those values or those constants will just cancel out, like in this case. So you never have to actually do this multiplication or division because in the end, there is none needed because this is lazy evaluation. And anyway, this is always lazy evaluation, right? All of the constants will accumulate and all of the units will accumulate, and only in the end you will get only one multiplication rather than needing to do, all of the multiplications on the way all the time. All right, so what is the HEP system that I introduced in MP units? Right, I basically looked for your domain and I tried to model this as exactly as your headers are provided. Right, ISQ is provided for a long time there, but ISQ is not good use case for you. Right, in ISQ you have 7 base dimensions: length, mass, time, current, temperature, amount, luminosity. Right, and energy is just mass, length, time. In the HEP system, you have energy as a base quantity and electric charge, not current, as a base quantity. That's why we have the system for HEP in MP units. You can go to our reference documentation and you will find that there is a HEP system that has 8 dimensions, 77 quantities, 33 units, and 33 constants as of today. Possibly it will be more if you request those or add those, right? We are open for contributions as well. And how you define those? First, you need to define dimensions. We have 7 dimensions here. And you just specify the dimension, specify the symbol for it, because you can print those symbols for every quantity to find out what is the dimension of the quantity. And also we basically use this for sorting and other stuff. And then we have base quantities of the system. You just specify the dimension as being the base of this definition. And you get the base dimensions and base quantities for the system. I also included here strong angular system, which means that the angular measure and solid angular measure are the strong quantities in your system as well. If it works against you because you have to modify some formulas, some equations, and you don't want to do it, let me know and we can make it dimensionless like ISQ does it. And then there will be no issue, but you'll be less safe. Both are possible, but for you to provide more safety, I provided angle as a strong dimension. But it's up to you, right? I can change it if you like it. Then you have units. We specify base units with just specifying for which kind they are. And we specify derived units by just providing the definition of them equation in the definition. Right? So with C++20, modern syntax, and TTPs, you can actually use such things in templates. Right? Before C++20, it was impossible to do so. C++20 is awesome and allows us to provide those one-line definitions for every entity in the library. Well, nearly every, because prefixes, for example, need two lines. But most of them are one line, and in one line you provide a symbol, you specify the equation, you specify the name, and you have to specify a kind or other stuff if needed, or a character. And then typically what we do, we provide also unit symbols as a separate namespace in MP units, because you don't want those to be typically in your projects, because those may collide with your current identifiers. But you can also using you provide using directive for this namespace, and you will get them inside of your namespace if you like those names. If you want to create the derived quantities, you just take those units, divide them, and you end up with quantity of mass, right? It's just auto, right? I don't have to specify its quantity of mass. The compiler will know it because those units were involved. The same here, right? This is just a concept. If you're not familiar with C++20, this is just a concept that verifies what was deduced by this template, by this auto here. Right? So this will be quantity of mass, this will be quantity of momentum based on the units you provided. Strong types, not just double values. But it looks exactly like your code right now, right? You write similar code today. But with this, you don't get Gabu, you get strong types that will just store the value inside, and the rest will be in the unit, right? So we never actually divide here by C2, at least eagerly. C squared, right? So our mass is actually megaelectron volt per C squared, the same as you do it, right? This is how physicists think. There's no confusion about C factors. Natural for relativity calculations still allows conversions to SI mass units when needed, as you've seen on the previous slides. Right, I mentioned briefly about proper time and coordinate type being different subkinds of time. And this is how basically you specify those. You specify those as being durations, and you specify those are specific kinds, which means they create separate subkinds, separate islands of durations that cannot be mixed with others implicitly. Right? So you can create a calculate Lorentz factor function that will take coordinate type at proper time and provide the division in the implementation. Right? And then if you specify those, of course, you can call them with the correct order. Incorrect order will yield compile time error, even though both are times, durations, right? They are still considered distinct types that cannot be converted to each other. So you have compile time errors. And you can convert them to the parent, to duration, with explicit cast like that. Right? So subkinds encode physics intent directly into the type system. All right, and what about the constants? Right? With the constants, after consulting with some of you, we decided to actually include code data 2018. So the currently used values for most of the projects as the default one. So if you type just HEP namespace here, you will and in constant name, you will get the value from 2018. If you want to get explicit new value or explicit old value, you have to be explicit, provide the proper namespace, right? This is not in the HEP namespace, it's also in 2018 namespace, it's just inlined here. So the types involved and used 2018 inside. It's just you don't have to spell it today. If you will move in the future, you can to the 2022, you can make this one inline, and then this one will, the code that uses those will just automatically move to the latest version being used. So you will not have to update all of the projects. If you are working with something that was like legacy, it will still work because you are explicit here. Right, so there's compile time selection. There's no accidental mixing of constant versions. Clear documentation of which code data is being used. Quite easy migration path as frameworks update. So this is a different level of safety, a different level of writing your interfaces, a different level of thinking about your code. How you can get there, right? I talked with John Chapman about that, and he said that you have lots of code. We have to prove there is zero performance impact, right, for your code, because if it's slow, then you don't want to use it. And you have to find out how to migrate this to not broke entire code base, right? So it has to be evolutionary, not revolutionary. And that ended up with such 6-phase approach plan to actually do it, right? You have to integrate MP units with your code, provide drop-in replacements for the current constant headers. New code can immediately start using MP units. You can wrap existing interfaces with types of overloads to get more safety. Then when you have more time, refactor internals, and then complete the migration, right? So in the phase 1, you just import, for example, math and the HEP system here. You include MP units to your namespace. So you use quantity, for example, directly in your namespace with no additional prefixes. And then you can specify any namespace you like. It can be MP, it may be HEP, it may be units, whatever you want, and put there the HEP system and unit symbol if you want to have them in the same namespace, because this is what you actually have as well in your project. Because your systems like millimeter and so on, your units are in your current system header file with no additional namespaces, right? You cannot bring them to CL HEP right now because those will just collide. I will have the same millimeters as you have, the same identifier, different type. So you cannot bring them directly here. You have to have some sub namespace for them, at least as long as you're going to use the current doubles, right? This namespace will be needed to isolate the identifiers. Then you can refactor your code that looks like that today into code that looks like this, right? This will be the same millimeters as you have today, being doubles, but you can use my library to actually create a quantity and get the value in specific unit, right? Centimeters in millimeters, giga electron volts in mega electron volts. Probably this will not change much for you, but you will have awareness that the unit library is there and that you can actually start using it. Because from basically from the code point of view, those are the same doubles. hopefully, if I provided constants correctly, and nothing will change, nothing will break for you, right? By the way, this static is not needed in your header files. You can remove it. It doesn't do anything. It's just application, just makes the code longer. Right, so the current code will just work because this is giga-volt being a constant, not my unit, right? My unit has to be in a sub namespace because of this, as I said on the previous slide. And having this integrated, you can start using this right away. You can write calculate momentum or other function with this syntax. I know that writing this prefix in front of units may be cumbersome, but you already reserved those names by yourself in your header files, so you cannot collide. Right, so the shorter namespace you choose here, this will be less painful for you to write. It may be even like one letter U, whatever you desire here, right? But something that is short and easy to use. And you can use those features right away, and then you work with strong types. And all of the safety that we discussed works for you, right? You create a quantity with the syntax, and if you specify them in different order, of course, you will get compile time errors, units will convert automatically, and so on. Next, you can wrap existing interfaces with type-safe overloads. So if you have any classes or functions, right, you can get this function and wrap it with another overload that will take strong types and just retrieve the numerical value, so a double, from within with correct unit expected by the underlying implementation. But the user will be facing those strong interfaces, and this will prevent errors at compile time right away. Right, and you can do this incrementally. It will not break any code. If you write this function by yourself right now, no one will use it initially, right? So it doesn't break anything. You can add it and start using it, and you have type safety for free. You cannot change getters at this point because we cannot overload on getters. So if you change getters, you may break potentially every user because they will get quantity, not a double, and my quantity is not convertible to double, so the code will fail to compile. Next, you can refactor internals, right? So if you get already quantities as an input, instead of converting this to a numerical value like here, you can actually make it store the quantity inside instead of doubles, right? And expose the old functions like setMass, where the old value like setMass here, the old function, to actually create a quantity of this type and call the other function, right? And you can provide deprecation warning saying, please stop using it because we are intending to remove it soon. You can also mark old getters with the deprecation warning saying, we are using in this class, we are using already quantities, please stop using raw getters for doubles. And you provide getters for quantities with a special name, special prefix or postfix, whatever you decide. Right, so it has to have different name because we cannot overload on a return type. And you can use this code in your safe code for now. Right, so this is safe code, you can use this. If you're in an unsafe domain, you get deprecation warning and you will be basically asked to update your code because the changes are coming. And in the last step, when everyone is actually fixed, right, everyone changes, we just remove the end, right? We remove all of those things, and we replace the getter to be nice again. We just remove quantity to get mass, and it works, right? You can just use one huge find replace to remove this postfix, to remove this postfix from the function, and it will work. I know that's a lot. I know that you have plenty of lines of code, right? I know that's not an easy process, but it's possible, right? It is possible. Yeah, you can do it in small steps, in baby steps, right? You can start playing with this, provide wrappers, as I said, in phase 2. Experiment with this, check the performance, verify if runtime doesn't change, and so on. What is what are the use cases? What is the benefits, and so on, and nothing breaks. Right, so experiment, provide feedback. We can improve the HEP system. Just let me know. Right, and then if you find it's worth it, then you can go with this step that provides you, that actually means that you are already committed to the change, and start doing the real change through longer time, because it will probably need some time for people to adjust and to update the software and their code to actually use modern interfaces rather than the old ones. Of course, you can also introduce one more step between 5 and 6, where you will actually basically introduce, when you remove when you remove those, you can reuse the same names and provide this and this function together, but both of them are being strong, so it's easier for people to move to the last version. But it's up to you. This is like minor adjustment of the process. All right, so let's talk about performance, right? Because I know that some of you are worried how much you will pay at runtime with that. For sure, the size of the quantity is the same as size of double. You can check it at compile time easily with static assert, right? So in terms of size, there is no overhead. Let's talk about runtime performance. The same function, right? Double, quantity meters per second. We have the same assembly code, right? Units are compile time only concept, right? If you want to divide doubles, you get the double division, nothing else in the assembly. No runtime overhead, right? This is for the division. Let's see maybe conversions or constructions, because this may be more interesting to you, right? Or maybe you may be worried about that. So this is the code you write today, right? You specify that you have value in millimeters and you want to return the value in centimeters, for example. And I'm doing the same here. I'm creating a value in millimeters and I get the number, so the double, right? Underlying value in centimeters. We get exactly the same assembly as well, right? If you will the same unit here and the same unit here, as expected, there's no work to be done. But this may be surprising to you, because if you actually use different unit here, like centimeter and centimeter, this is what you get in the current code rather than that. All right. So actually using strong type system may be faster for you than actually using plain doubles. Also, the fact that we are using lazy evaluation, lazy constant multiplication in MP units in strong type system may also prove you some performance, because instead of using multiplications with some constants in every line of code, you will have only one multiplication by one constant in the end when you want to convert to a specific unit, and the constants will just accumulate as a part of the type, not a part of the value right away through the calculations. So this may also improve your performance in those cases. As I said, MP units is basically proposed for standardization. There are 3 papers you can check if you're more interested in this. This is the latest paper with all of the details. Those are older papers with some motivations, short paper, and this one was about the domain in general. But this one provides all of the details about the library. But you can also check our documentation online for MP units. It's great and provides plenty of information. The current status was presented to LEWG, Library Revolution Working Group, in ISO committee. We got positive feedback. We use MP units as a reference implementation for the discussion, and we target C++29 as of today. We're going to talk about this like 2 weeks from now in London, during the London meeting, and possibly there will be some update on my website in our blog about the progress. So stay tuned if you're interested. Why actually it's important for your industry, right? You're investing in the future standard library, right? If you will try it out today, we'll have better feedback and we can actually improve whatever gets to the standard in the future. We still have time to modify something or to fix something if it doesn't work right according to your needs, right? So if you start using this right now, MP units, and something will not be as great as you would like it, we can improve it before it's standardized. It's easy to complain after something is standardized by the committee that we did something wrong again, right? But right now you have the possibility to actually influence the design that will be in the standard in the future, which is a huge benefit for us, for sure, and probably for you as well. because you will be the future users of the standard, not MP units, right? And in the end, you will get it as a part of every compiler. You will not have to depend on my project, right? And why actually my project, right? Why my project? Well, besides that it's going to be standardized probably, my project is the most active one and the most successful one right now on the market, right? Me and a group of contributors are contributing to this project. We started in like 2019, and this is our line, right? This is how we tend and how we progress. There was another library before. I started earlier, but it doesn't get so much traction. And there's also a really nice library for Aurora units written by one of our contributors. That's also really nice. It is on C++14 if you need, but it doesn't provide all of the features that we talk about and will not be a part of the standard. Right? I have here a detailed comparison of all of them. So if you want, you can look into the slides and compare them. I will not spend time to discuss all of this. I just want to mention that I'm planning to provide MP units v3 in near months. It will be mostly API compatible, so don't worry about the breakage. It will maybe just change the affine space a bit, abstraction, and will basically change some concept names to the standard ones that are requested by the standard committee. Because right now I'm using camel case for the concepts, and in the end we are going to use the standard case. But that's not a huge deal to refactor, or basically I will also provide the deprecation warnings and will provide a long time to actually fix it. So no major changes, only improvements and more features in v3. And this comparison to boost units, Nick Holthaus, right? So the other one, this the blue one here. SI Bernadom is the one yellow here, and the Aurora units, that's the newest one in the end. And you can find that actually MP units and Aurora one are the ones that have the most things covered properly. Right? Aurora units even have really nice here representation safety improvements that I don't consider important for now, but maybe I will change my mind and also implement this in my library. We are talking with ChipHawk about this. But for now, Aurora units is ahead of my library in terms of representation safety. But they lack kind safety and quantity safety. And they do not have dedicated HEP systems built in. All right, so to summarize, right? I would encourage you to write some simple prototypes. Right, prototypes phase 1 and 2 that I mentioned provide a namespace for units in your project. Right, maybe try the drop-in header replacements. Benchmark, verify if there's actually at runtime if there's an overhead. Right, pick up some subsystem and maybe try phase 3 with the subsystem to find out how it works for you. Right, what are the interfaces, what are the potential issues, or what are the benefits that you find. Right, then you may consider actually providing a bridge between two projects to make it type safe, right? To make those conversions automatically for you, so you don't have to actually work on this all and remember about this all of the time, right? Train the developers, tutorials, documentation on how to use it, how to fix it, and how to improve your code. I can help with that if needed. Just let me know. And establish your coding guidelines for type interfaces. And in long term, hopefully you will end up with full type API across all of the projects. I know that's a long term, but it's possible, right? If possible, please contribute back to the project, right? Please try it out. Please provide feedback. As I said, everything that we are going to get from you as a feedback will potentially improve the future C++ standard. So it's important for us to get feedback from you as soon as possible, especially that you are a bit different user than the rest of our community because you use different system of quantities. I initially thought that you're actually using natural units, like the C equals 1 and other stuff, which is totally different, but it's not the case for you. But if there are any people maybe doing this on the side, not in maybe in those projects, but in other projects, like using natural unit system, let me know, contact me, because I'm really eager to hear feedback from you on how we can make it work as well. All right, because natural units is also something that I should cover in the library. I want this to be possible in the future standard version of units, but we don't have many users that actually do it. So maybe there is someone in the room that actually has a different side project working in such domain, let me know, contact me, and I would really be happy to help you with that and to try my library in such a setup. Right? So to summarize, right? We have 7 physical dimensions, and all of them are right now zero-dimensional double in your code. That's a huge problem for the compiler because it cannot help you. You have to depend on engineers, on code review, right, to make sure that everything is correct. Right, with MP unit, you will restore all the dimensions at compile time with 0 cost and runtime. Right? In the dedicated system, you have energy as a base quantity, matching how you think, how you write your code. We have 6 levels of safety, plus bonuses that I shown you. I provided you some plan for migration. Of course, you can use different one, but this is my proposal. Right? And the bugs that probably all of you, sooner or later, or earlier, written in your code are really preventable at compile time. Right? The compiler can help you, but you have to provide enough information to it to make it work. And that's basically it from me. Thank you for listening. Thank you for being here. Let me know if you need something more from me, if you would like to have some additional information or would like to actually change something in the provided system. I'm really eager for feedback. I don't know if you have time for questions because we have only 3 minutes left, but you can contact me offline easily and we can discuss stuff. I love talking about C++.
I think we definitely have some time for some questions. Thank you very much for a really nice presentation. Attila, I see your hand went up first.
Yeah. Okay. So I won by a little bit. So thanks a lot for the presentation, Mateusz. Since you called out the Atlas source code quite a bit, when it comes to that source code, you might end up talking to me on what could actually happen. Since we have just limited amount of time, out of curiosity, what would be the biggest customer of MP units at the moment? Of biggest customer of any type? Especially in terms of size of their code, that sort of customer.
My libraries are used in some automotive domains already, and some also industry stuff. So yeah, it's being used there. I have positive feedback, but I am not having the possibility to actually look into their source code or know their size. So those are just people coming to me at conferences saying, "We are using this in production. It is great. Thank you for doing this." But I have no exact possibility to actually see what they are doing.
Okay. So my comment here would have just been that you saw CLHEP, you referred to CLHEP a lot. We do not use CLHEP everywhere. That was the goal back when CLHEP was first designed, that, hey, let's have one definition of everything. In practice, that never worked out. And this would be my big worry about any future library as well. But I'll let some other people ask technical questions as well.
Okay, thanks, Attila. David?
You're muted.
You're muted. Hardware muted, probably. Oh, software.
Sorry. Yeah, if we go to David now.
Still muted, David. Maybe hardware muted. Check your headphones.
Is it okay now?
Yes.
Okay, sorry. 3 questions are important, and if you don't have time to answer, not a problem, but I want to list them because in my mind, I think they are showstoppers. First point, how is it easy to mix MP units with linear algebra libraries such as Eigen? First point. Second point, do we have control on the internal unit which is used inside? If we want to control the floating points errors, we need to master how it is stored, which numbers are stored in the mantissa inside the numbers. And the point 3 is if we want to adopt MP units, can we adopt it easily without Conan? Because actually it seems Conan is the main way to deliver the thing, and we can't ask root, chain4, Atlas, etc. to move anything into Conan. Finished.
Sure. All right. So yeah, there are people using MP units with eigen already successfully. Of course, this is only possible in case you are using the homogeneous matrices or vectors, right? Because if you want to use heterogeneous quantities, like for example Kalman filters or other stuff, then eigen will not handle that, right? But as long as you have homogeneous matrix or vector, it should work, right? There are possible layers on top of physical units to actually use heterogeneous matrices. I have projects related that I can recommend or refer to that actually using this for Kalman filters with MP units. So contact me offline and I will show you how it can be done. But it requires some additional layers to actually decompose the units from the values and put them in eigen, for example, and then work with them in a type-safe way. But in case of homogeneous matrices, like for example for force or for some position vector with 3 or more components, that's not an issue, right? So your 4 vectors also should work assuming that you're using the same unit all the time. And I know that's the case for some projects, but not for all of them, because the fourth one time, sometimes it's time, sometimes it's not time. Second, you asked about the internals being stored in a quantity. There's nothing like this. You just store the value you passed. So if you say it's a millivolt, it's millivolt. If it's microvolt, it's microvolt. I'm not converting to SI all the time, right? I'm storing the value you passed and the unit you passed inside, and you will just convert it when you need it, right? Within or by converting to another quantity of a different unit. So basically, you exactly store what you use rather than converting to some base stuff in a SI unit. And the last one was about the Conan. Yes, this is header-only library, right? Of course, Conan is recommended for my users, but if you don't like Conan, you can just put the headers in your project or make a subrepo or make a, I don't know, Git sub, Git subrepo or whatever, and include this there, right? Or you can use also with CMake some fetch content or whatever. There are users using this in so many ways. You can find exactly information about this on my installation page in documentation.
Yeah, I just recommend perhaps that you make an explicit list of dependencies, which, as far as I know, is lacking in the documentation. You have to discover it in the CMake files or the Conan package, but you don't have the list.
Because there are none, actually. The only dependency that is needed for framework is a GSL Lite or MSGSL or none. Because you may say you don't want to have contract validation. If you choose none, you have no dependencies. It's self-contained. Okay. Because there's also an option for a language contract that I hope will be in C+26 in 2 weeks from now.
Okay.
Mm-hmm. Okay. If we go to Dan now.
Yeah, I wanted to say thanks. This is incredibly cool. I played a little bit with Chrono, and I think it's really nice how you have like a difference in, an absolute coordinate and displacement. I feel like that would save a huge number of bugs. But yeah, as was just mentioned in the last comment, I think, getting it to work with like a system of vectors and stuff would be like a really important extension. Anyway, this is just sort of a comment that seemed a little funny to me. You have a lot of like factors of C and C squared here, which is, I don't see anywhere in Atlas code, of course, because of a few reasons, but it's more of like a comment for everybody. I don't know, would we actually want to treat mass and energy as separate units? I mean, because in like HEP units, it's totally acceptable to say like take a kilogram and minus a joule. Like that's like a totally well-defined thing in terms of the units that we're used to using, right? So I think the system you have is flexible enough that we could just, basically drop either mass or energy and define all of them in terms of the other. But I wasn't really sure if people would want to go that way or not.
Sure. If you will assume that C equals 1, then it will
work.
Mm-hmm.
So I think it's an interesting convention, I wouldn't have a problem with adding C everywhere, but I wasn't sure what everybody else would actually want to do.
Mm-hmm. Yeah, but I use the C not for actually computation, but to just express the unit. So you know that you're dealing with energy rather than mass, right? It was never used actually in computations.
Mm-hmm. It might be worth adding that then I think it's not really mass and energy where we would ever care about the difference. But technically, I've seen problems between energy and momentum in a couple of places. That can get confused.
That one is really interesting, actually. I was thinking about that too, because that would be like more like a type maybe as you're referring to it. I mean, saying like subtracting an energy from a momentum doesn't really make any sense, but you allow for things to have the same units, but different types, which would make that incompatible, I think. So I think the system is actually rich enough that you've developed to account for what Attila is mentioning.
Yeah, with c equals 1 also you will make time and length being the same and speed being dimensionless. But yeah, it's possible. It's actually my other namespace, the other library that or system that I said, the natural units system actually tries to model this and uses this already.
Oh, okay, cool. That's really, so I guess I should just look at the natural units version. You're saying that's also in there.
Yeah, just provide feedback because this is hugely experimental right now.
Okay. Okay, cool. Thanks.
Sure.
Okay, thanks, Dan. And Nick?
Yeah, a question and a comment, but actually I'll start with the comment because it follows directly from Dan. You know, in CLApp having CB 300 probably actually helped us, you know, find some bugs ahead of time because the thing that came out was just crazy high. And I think that the choice of moving to natural units is really just a choice to give up kind safety, using Mateusz's language, right?
Yes,
Because as I
because
understand
you're
it,
not.
yeah, as I understand it, you know, kind is a level on top of type that also ensures that you're, you know, in what part of the equation this quantity belongs, right? And moving to natural units, people often, you know, it allows them to throw away C's and just, you know, I think it implies that you're giving up some level of kind safety. So I wonder if it just brings you to the same.
Yes and no, actually, right? This is true that, for example, length and time becomes the same thing, right? And speed becomes dimensionless, for example. But you can still model them as branches in a tree of the same quantity kind, right? Like right now you have length and, for example, radius, or width and the radius, or width and the height, right? Being different quantity of length, and you cannot mix them. You can say also length and time are being of the same kind, but you cannot mix them, right? But you can convert them to the parent node. So this kind thing, but not to the length and time directly. So you can do it as well and still keep some type safety in your domain, even with natural system. And this is what I tried to do actually in this experimental one. I know that there's some things that do not work yet because I didn't have enough time to finish that, but I played with this approach a bit.
So you're saying that you can, because you give the ability to have kind safety, but you say that people can let it sort of, I'm trying to look for the right word, like downcast or something to the type.
Yes,
In
because we have
certain regions, if you don't want to be as rigorous. Okay, I understand now. My other question was,
Maybe,
and this is probably just obviously true, is do prefixes accumulate the same way that constants accumulate? In the sense that they're exact and only resolved. Like if you have a sequence of factors of 1,000 and you know factors of 1 over 1,000, that it cancels that.
Yes.
So that brings up an interesting problem that we might encounter is that if our old libraries, which are not accumulating those factors, compute derived quantities in the header, they may be, because of the choice of associativity in the header and the choice of associativity that you use in your library, may lead to different floating point values. So it may be possible that expressing things in your system will give, you know, because of the lack of floating point associativity, will not give the exact same set of values as in existing headers.
Yes, and it sometimes happens, right? When I compare operations on doubles and compare operations done by my library, for example, I will see the same operations like multiplication and division in assembly code. Both of them are in the same. The assembly code is the same length, but for example, that doubles first multiply then divide, and my library first divides and then multiplies, right? So it may yield a bit different results in a floating point domain, but those should be quite accurate for you.
I guess it's just
And
something to watch out for, that it may be
yes,
epsilon away in some
yeah,
cases.
it might be epsilon away. Yes. Just to come back to the previous question, I just found the tree of natural energy. That's actually is acceleration, mass, momentum, and temperature, for example, right? So you can model it this way: that you have energy, and all of those will be together, right? And I have the system natural here that you can find, for example, length, and length will be inverse energy, and you can look into the tree of inverse energy, and the tree of inverse energy will be length and time, right? So those are the children of this tree, so you cannot convert between those easily. However, you can add them or compare them, which is a problem. You can make them separate units here, separate subkinds with is-kind as well, so you'll not be able to compare them and or add them, but it depends on use cases, right? So the framework is really flexible to model anything you want, right? Just provide me your requirements, and I can help you model you the system you need for your computations. But I have all of those in my reference. You can find all of the systems here, and you will find all of the information about all of the systems here and how they are being defined. There's also the user's guide systems, where you will find the description of most of the systems I have in the library. Basically, documentation is hundreds of pages today, lots of information. So you'll find everything you need probably in documentation. If not, let me know. I will add it.
Okay, excellent. Thanks, Nick. And Frank?
Yeah, thanks a lot for the talk again. So this is a question exactly to relate to what you just showed. So our software, we're using a lot of externals libraries as well that are outside of our domain. Let's say one of these libraries decides to use the ISQ system. We're using the HEP system. Both of them define a quantity of length, which may or may not have the same base unit. So, but they're treated as different types in your library. So how do you make
Yes.
these compatible?
Well, if you want to make those work, you'll need to provide some conversion functions by yourself, right? There is a reason why you create a totally different system of quantities and then totally different system of units based on the system of quantities, right? Because you want to have totally different abstractions, and those abstractions will not be possible to be transitive between different systems, right? So if you want to be compatible with ISQ, you then have to admit and use ISQ. It is totally possible, but then you will have mass as a base quantity rather than being energy as a base quantity. It should not affect much your actually computations. Maybe the simplification of some types will prefer mass rather than energy in some cases. So you may end up with different results a bit during the simplification of different equations on the quantities. But in the end, you should have the same numerical results and the same performance.
But do you have to do the conversions explicitly, or like in the example of length, for example, which just happens to have a different base unit?
No. If you have ISQ and HEP today, those are totally independent two different systems that do not know how to cooperate with each other. All right. If you need something to be compatible, we can think about something like this. Like, for example, we can import just length, time, and mass from ISQ, or length and time from ISQ, but all the rest will be provided differently. We can do it the same way, right? Because we can basically use length and mass from ISQ, and then meter from SI will be correct for you. And then specify that energy is, for example, base, which will be different, and this will not be compatible with the ISQ. But I don't know how it will work. We need to experiment. If you need something different, it cannot work easily by itself.
Yeah, it might be worth thinking about this a bit, because especially since we're using so many external libraries, not all of them will be in the HEP system once this, especially once this gains large adoption.
Yeah, but you can provide like a custom type safe conversion functions between one and another system, and it should work.
Okay, and finally, Maria.
Yes, looking at the attendance of this meeting, I'm probably the historical memory of the Jan4. The Jan4 system of units that was developed in RD44, it's more than 30 years old by now. And so maybe some rejuvenation could be useful. But it was the result of lots of discussion with the developers and users. So what I would recommend you is to be one of them and to be in touch with them, because one single person can hardly, collect the experience from the wide user in many different communities. And John 4, for instance, is used in energy physics, in medical physics, in archaeology, in fisheries, in food industry, and whatever. So this would be useful. And one of the arguments that was most debated in the old days was the simplicity of use. In the Gen 4 system of units that then was donated to CLHEP, you write 3.5 star MeV as you would write on paper. It would be desirable to keep such simplicity, which requires also some discipline to use it correctly. For instance, the examples at some point, you showed an example of mismatches between root and Gen 4. If you don't use the system as is in Gen 4 now, as it is supposed to be used, obviously you may get mistakes. But behind that, there is the idea of keeping it simple, intuitively to use without writing meters and meters of long expressions that don't resemble what you write on paper. And this is what physicists easily understand. So I hope that your system, if you plan to move it into some ISO standard, can keep this simplicity of use, simplicity and intuitiveness of use. Otherwise, it would fail. Physicists would use something simpler.
Yeah, sure. I totally understand it. Thank you for this feedback. Yes. I don't know if you followed, but maybe some of you followed my talks on different conferences. The design of this library from the very beginning was basically constrained by the ease of use and the user and the user experience working with the compile errors or debugger, right? I don't know if you have any experience with boost units, for example. Boost units will generate you errors on pages of screens for one type, right? This library provides really nice and easy to use and understand error messages with short types. The syntax to actually create quantities, exactly as you said, is just a number and a unit. Unfortunately, because you use the unit in your namespace, you have to provide additional namespace for the units to mean something different. But otherwise, it will just be exactly the same as you written. And the only difference will be that you don't get a double as an output, but a quantity written this way as a strong type. I know there's more to type than just double, but that provides you the intent, right? Double will provide the same thing for all of the quantities and units. With this, you provide explicitly what you mean. And you don't have to use those typed quantities like provide specific length or specific energy or whatever here, as long as you don't care about them. If the function takes only one energy and one mass, you don't have to specify what kind of energy or what kind of mass it is, because it's just only one of them, right? If you care in specific place about not mixing those, as I shown you in some examples, then only in those cases, you specify, like here, specify exactly what time do you mean, because both of them take time as an argument. So if you just specify a quantity of nanoseconds, you will be able to mix the units and the order of arguments. That's why you are here more explicit about which time you mean. But it's not mandatory, it's only needed where it's needed, right? A quantity and a unit is enough for most of the use cases. So it's quite simple to use. I hope that this answers your
Well, you
concerns.
may want to try to develop a new physics model for Gen 4 and using your system, and just that how it looks like a hell for a physics developer. But that's another, comment based on different kind of experience. Okay, thank you.
Yeah, I know that many of you are not C++ experts. You are engineers. You are physicists, right? That just use C++ as a tool. And yes, we really try to keep the library simple. And the new syntax from C++ actually allows it to be simple and nice. But of course, there is some overhead, there is some path to learn, and yeah, I know that it might be harder for you to just get from doubles to play with templates.
I think I consider myself a fair expert in C++ since the very old days. So I don't accept this generalization of how physicists behave. But anyway, that's fine. Thank you.
Yeah, I'm very happy that you got some pushback on that, because millions of lines of code don't just happen. There are some actual experts around here as well.
Yeah, sure, of course. Yeah, I know. I'm just not saying I know better, right? I'm just saying there's a tool that you can consider for usage, right?
Okay, I see, Tim, you've got your hand up as well.
Yeah, this looks like a fantastic system, and I really hope we can adopt it. I've got a number of specific questions, but I mean, one just general thing to discuss here. I'm interested in you're seeing this would then migrate in the longer term when it gets adopted into the C++ standard, because at the moment I see you've got an HEP namespace with all our HEP units, and I'm assuming that we wouldn't have standardized as in part of the ISO C++ standardization, the HEP thing, that we would be using some core set of definitions from that. Is that how you see it working, or how do you see we will migrate from using MP units to using the standard colon units, I guess it would be?
Sure. Let me maybe bring the code on the screen so you can see the actual code that has to be run when this will be a standardized stuff. Basically, this is the definition of all of the units you use, right? And those are in MP units namespace. Actually, in your HEP namespace, right? The only thing that you have to do when actually standard comes, and probably I will do it in my library anyway, this will just prefix std in front of every quantity here, right? You'll just put std named unit, std name unit, and you are done. And you can just use it with this definition of your system, right? Those are short header files with one line per entity definitions. And those will just be probably just std named unit, for example, in the standard when we standardize it. So it should be really simple to actually have your custom headers with custom systems. I will be also still keeping MP units, and will provide extensions to the standard ones, right? So we'll be having more systems, maybe more features than the standardized in MP units. But it should be quite easy to migrate, right? Basically the same happens with libfmt for formatting, right? There is still FMT right even today, even though the format is already standardized for 6 years. So this project is not going away, and it will be compatible, of course, with the standard.
So we'll keep using MP units even after it's standardized, but it will be just a much stripped down thing that will rely then on internally on the standard. Thank you. That sounds excellent.
Sure.
Okay, good. I think we've come to the end of the questions. So yeah, I would like to thank you a lot again, Mateusz, for coming to speak with us. And yeah, you said you're happy for us to contact you with other.
Sure, of course. I love talking about C++. So just let me know.
Wonderful. Thank you everyone for joining, and yeah, we'll see you at the next seminar.
All right. Bye-bye.